This video will cover the destructive test of a light frame wood structure model with the roof harness system applied. This test is the second part of a comparative study investigating the behavior of a light frame wood structure model with and without the roof harness retrofit system. This test uses an identical roof and model configuration to the one used in the unretrofitted displacement test, where, this time, a retrofitted system is introduced to the roof. The retrofit is a reduced scale version of the roof harness system developed by Michael Shore, president of MA SteelCon, and Dr. Ashraf Eldamati, professor at Western University, by MA SteelCon Engineering, and Ryan Jacklin, under the supervision of Dr. Ashraf Eldamati. Like the roof of the reduced scale model, the components of the retrofit system have been specifically designed to emulate the behavior of the full-scale structure and retrofit system under similar wind loading conditions. This is done by reducing the cross-sectional area of the cables and spreader beams. Visible in the test setup are the S-load cells connected to the retrofit cables, which are used to monitor tension and measure applied pretension. Just off screen to the left is the pitot tube, used to measure wind velocity. Once again, this test will isolate toenail withdrawal at the windward roof-to-wall connections as the desired mode of failure. Displacement at these connections is continuously monitored as the wind velocity is increased over an applied range. Let's take a look at how the system performed. Footage of the test begins where the fan speed is increased to approximately 44 miles per hour and held constant for 30 seconds. At this point, the displacement at the roof-to-wall connections indicate that these locations have just achieved initial separation, as the own weight of the roof, plus the pretension force, is resisting the applied uplift force due to suction. 44 miles per hour represents an 11 mile per hour increase in velocity at which this failure stage occurs, as compared to the test of the unretrofitted structure. This is largely due to the presence of the pretensioning in the retrofitting system. At approximately 67 miles per hour, roof-to-wall connection 3 begins to experience significant withdrawal, followed shortly thereafter by roof-to-wall connection 2. The wind velocity at which this event occurs is improved by approximately 18 miles per hour, or a 144% increase as compared to the unretrofitted test. This improvement is a combination of the effects of pretension and load sharing between the retrofit system and the roof-to-wall connections. The mechanism of load sharing is engaged as the roof-to-wall connections begin to withdraw from the top plate. As the stiffness of the retrofit system is predominantly linear, while the roof-to-wall connection stiffness is nonlinear, load transferred from the roof-to-wall connections to the retrofit system follows the decay in toenail stiffness. At the end of the video, the wind speed is sustained at 81 miles per hour for 30 seconds. This is the highest wind speed the current wind tunnel configuration can produce, and, as is observed, only the interior windward roof-to-wall connections experienced full withdrawal. Using finite element analysis models to predict the behavior of the structure in retrofit, the predicted wind speed at which all roof-to-wall connections withdraw is determined to be 91 miles per hour, an approximately 70% increase in wind speed as compared to that same failure event in the unretrofitted structure. At this point, though all roof-to-wall connections have achieved full withdrawal, the roof is prevented from overturning failure by the presence of the retrofit system. To summarize, the retrofit system has shown 3 clear benefits. 1. It prevents catastrophic failure of the roof by overturning. 2. It significantly increases the wind speed at which a gap in the building envelope can form. And 3. It limits the size of that gap by restricting the overall displacement of the roof-to-wall connections. Applying these results to a full-scale structure would mean that, without a retrofit system, failure of all roof-to-wall connections and overturning failure would be observed at approximately 55 miles per hour, while with a retrofit system applied to a full-scale structure, only small separation along the windward edge would be observable at approximately 81 miles per hour, with the roof held safe and secure and stable from overturning failure at almost 81 miles per hour. This means that even at Category 1 hurricane wind speeds, most homes with the retrofit system installed would hardly see any damage. Thank you for joining us, and we hope you've enjoyed learning about the roof harness retrofit system.